All right, suppose an income stream has a value of P of T equals 1,000 plus 200 T dollars per year. Further, suppose that the income that comes in is instantly deposited into a bank that pays 5% interest compounded continuously. What is the present and future value of the income stream over a period of 15 years? Okay, so it's really helpful to start by drawing a timeline. So here's time 0, here's time 15, and we're going to pick a random time location somewhere in there, totally random, and we're going to create a little slice of time at that spot. So this small amount of time later, t plus delta t, which means that this length of time is delta t. And then the time from 0 to t, that's t years. And then the time from t to 15 is 15 minus t years. So it's just helpful to have this visual before we start. And then we're going to consider what happens on this one small slice. Okay, so I want the future value and the present value of that one small slice. So let's start with future value. So future value is the present value times E, and I'm projecting forward to year 15. So from year T to year 15, that's 15 minus T years. And my interest rate is 5%, 0.05. Okay, now I need to figure out what the present value of that is. So that's delta T years, and I have a income stream of 1,000 plus 200 T dollars per year. So I have 1,000 plus 200 T dollars per year times some small amount of time, delta T years, E to the 0.05 times 15 minus T. So that is the future value of that one tiny slice of time. And then I'm going to add up all those slices from 0 to 15. So I'm going to sum up n of those slices. Each slice is going to have a future value of 1,000 plus 200 T sub I, E to the 0.05 times 15 minus T sub I, delta T, and then I'm going to take a limit as n goes to infinity. And I end up with the integral 1,000 plus 200 T e to the 0.05 times 15 minus t dt. And my bounds of integration are going to be 0 to 15 years. And this comes out to approximately, I just put it in a calculator, future value $51,700. Okay, then I'm going to do a similar calculation for present value. Changes just a little bit. So present value is future value times e to the negative 0.05, because now we're going backwards in time. And I'm going backwards in time from time t to time 0, so that length of time is t years. So the future value is the income stream 1,000 plus 200 T delta T. That's the amount of money that comes in on the interval from T to T plus delta T. Then I'm sending it backwards in time, T years at 5% interest. So that is the present value of my tiny slice of time. Then I'm going to add those all up. N slices. I goes from 1 to n. Each slice has a present value and then I take the limit as the number of slices goes to infinity, and that is an integral. And I'm going to integrate from 0 to 15. And that comes out to 24,000. Again, I'm just evaluating this in a calculator for this one. $24,421.35. Okay, so now I want to find the future value of an income stream of $1,000 per year. 8% interest compounded continuously over a 7-year period, and evaluate the integral by hand. So again, I'm going to start by drawing a timeline. I'm starting at time 0. I'm going to year 7. Pick a random time location in between 0 and 7. And I'm going to look at a little slice of time, t to t plus delta t, which means the length of that little slice of time is delta t. And then this distance from here to here is t years. And the distance from t to 7 is 7 minus t. And now we set up the value of my little slice. The value of my little slice. Well, I know that I'm looking for future value. So the amount of money that comes in on this little slice of time is $1,000 per year times delta t years. And then I'm going to send that forward into the future for 7 minus t years, earning 8% interest. So that's the future value of my tiny slice. And then I'm going to add up all those slices. Each slice has value 1,000 e to the 0.56 minus 0.08 t dt. I just distributed the 0.08 there. Then I take the limit as the number of slices goes to infinity, and that gives me an integral. Integrating from 0 to 7, 1,000 e to the 0.56 minus 0.08 t dt. And then I'm supposed to evaluate this integral by hand, which means I need to find an antiderivative for the integrand and then evaluate it from 0 to 7. So we're going to do some side work here. I just want to work on finding an antiderivative for the integrand. So let's do that on a separate page here. So I want to find an antiderivative for 1,000 e to the 0.56 minus 0.08 t dt. So first of all, I can take the 1,000 out of my integral. So this is 1,000 integral of e to the 0.56 minus 0.08 t dt. So that's e to some stuff, and the antiderivative of e to the x is e to the x plus c. So I'm going to replace that stuff, 0.56 minus 0.08 t, with a u, do a u substitution. So I'm going to let u be 0.56 minus 0.08 t, which means that du dt is negative 0.08, which means that dt is du over negative 0.08. So this is 1,000 times the antiderivative of e to the u. And then instead of dt, I have du over negative 0.08. Pull that 1 over negative 0.08 out of the integral, 1,000 divided by negative 0.08, times the integral of e to the u du. Let's get a calculator to evaluate this constant. 1,000 divided by negative 0.08, negative 12,500. All right, then the antiderivative of e to the u is e to the u plus c. And then I'm going to replace the u with the original substitution. So negative 12,500 times e to the 0.56 minus 0.08 t plus c. So I've got my antiderivative. And I'm going to go back to the previous page and use that to evaluate the definite integral. Okay, so this is negative 12,500 e to the 0.56 minus 0.08 t. I don't need the plus c when I'm doing a definite integral. I'm just going to evaluate this from 0 to 7. Okay, so when I plug in a 7, I get negative 12,500 times e to the 0.56 minus 0.56. So that's e to the 0, which is 1. So I get negative 12,500 when I plug in 7. And when I plug in 0, I get negative 12,500 e to the 0.56. All right, so let's get a calculator to do this. Negative 12,500 minus negative 12,500 times e to the 0.56. And I get about 9,383.41. 9383.41. Okay, we're skipping number 3. Number 4. A single deposit of $10,000. We just want to find out what interest rate would give us a future value of $20,000 60 years from now. This involves no calculus. It's just some practice with the formula. Future value is present value times e to the RT. Future value, $20,000. Present value, $10,000. E to the interest rate is what we're looking for, 60 years. So I just need to solve this for r. So I'm going to divide both sides by 10,000. So I get 2 equals e to the 60r. Take the ln of both sides. I get the ln of 2 equals 60r. And then divide both sides by 60. R is the ln of 2 over 60, which is approximately 0.01155. And when you convert that to a percentage, that is 1.155%.